Hey guys, so we are going to take a look at 5.1, and a lot of this is going to be built off of the identities that we've seen before. So I'm going to go back and actually put together this worksheet. It's on Canvas. It's just all the identities put together on one sheet, so you can see them all at once. I also put together a totally filled out unit circle, which we should have memorized at this point, but if you need to drill yourself on it or whatever, I also printed out one of those on Canvas. All right, so 5.1, we are going to use fundamental identities. All right, so one of the identities that we should be familiar with at this point is that secant is the reciprocal of cosine. So I'm going to say 1 over cosine of u equals my -3/2. All right, and they told us that tangent of u is greater than 0, like a positive. So on my unit circle, which this unit circle we should have memorized, I gotta know where my tangent is a positive number. Since my tangent is a sine over cosine, or in other words, a y over x on my unit circle, if I know the signs here, let's see, I got a positive x, positive y, negative x, positive y, negative x, negative y, positive x, negative y. So there's the signs of each quadrant. And in order for my tangent, my y over x, to be greater than 0, see, I would have to have either a positive divided by a positive or a negative divided by a negative. That would end up greater than 0. So I've narrowed it down to 2 quadrants, and then also my cosine. Let's see, 1 over cosine is going to be a -3/2. And cosine is always the x on my unit circle. So I'd have to have 1 over some negative x value to end up with a -3/2. So my negative x's out of these two options, my negative x's are here in the 3rd quadrant. Okay, so we have narrowed it down to quadrant 3. And so we are going to draw our triangle here. I put theta, but I think they're using u. So I'll put a u there. All right, so cosine of u, well, let's go back to secant. I used the cosine because that had to do with either an x or a y on my unit circle, but they originally said secant of u equals -3/2. And secant is the reciprocal of your, well, it's your hypotenuse over adjacent. Cosine is adjacent over hypotenuse. Your secant's the reciprocal. It's the hypotenuse over adjacent, which means my hypotenuse is got to be that 3, and the adjacent has to be the -2. So hypotenuse 3, the adjacent to my u here is a -2. All right, I should always have a positive hypotenuse. It's the x's and y's that can be negatives. All right, so I know 2 of my 3 sides. Let's find the 3rd side here. So a squared plus b squared equals c squared. All right, so I've got a 4, and I need to subtract that 4 over and get a 5, and then I will take the square root. Now, when I do the square root, I usually have like a plus or minus, like either a positive or a negative, and because I'm in quadrant 3, this has to be a negative y value. So out of my plus or minus, I need just the -√5 in this case. All right, so if I have all 3 sides of that triangle, I can find whatever trig functions they want. And they said they wanted actually all 6 trig functions. So let's see here, I can do sine of u, cosine of u, and tangent of u. And then I'll do all the reciprocals. I will do my cosecant of u, secant of u, and cotangent of u. I think they actually already gave me my my secant of u is -3/2. So I already have that one. I got the 5 others to find though. Sine, let's see, sine is opposite over hypotenuse. So those guys right there, a -√5 over the hypotenuse 3. Cosine is adjacent over hypotenuse, so the -2 over 3, and tangent opposite over adjacent. negative root 5 over 2, negative 2. This one, I do have a negative over negative, so I'm going to turn this into a positive root 5 over 2. All right. And now I can do all of their reciprocals. So I will get a 3 over a negative root 5, which we don't like having denominators as square roots. So we're going to rationalize the denominator. I get a negative 3 root 5 over 5. This one we already found, and it has a rationalized denominator. That's fine. So last one here is our cotangent. It's the reciprocal of tangent. And I need to rationalize the denominator one more time. Okay. So there are all 6 trig functions. Okay. So next up, number 2 here, they want us to simplify the expression. This is going to have a lot to do with our identities. In fact, because I see this cosine squared, that's kind of thrown in my head here, one of my identities that I remember about sine squared plus cosine squared. So I'll show you this, what I'm talking about. When I saw that cosine squared, it's kind of making me think about this identity. All right, so let's see what I can do to simplify, and I'll probably use that identity in one way or another. All right, so first things first, I think I'm going to factor out a sine of x, which means I have a cosine squared and then minus 1. All right, and this cosine squared of x minus 1, I think this is what I'm going to use that identity on. Cosine squared minus 1. Okay, here's my cosine squared, and my 1 is on the other side. So it looks like we need to kind of rearrange things a little bit. I think I'm going to subtract the sine squared on both sides. And then I will subtract the 1 on both sides. Okay, so this is what I had in my problem. I had a cosine squared minus 1. And it looks like that's going to equal a negative sine squared. Okay, so cosine squared of x minus 1, this is going to be my negative sine squared of x. Okay, which means if I simplify this all the way down, I will have a negative sine cubed of x. All right, so that's kind of as good as it's going to get right there. All right, so that's totally simplified. Let's try this on the next one. And I have kind of the same indicator. I've got this cosine squared, so that's really making me think I'm going to use that same identity. But let's factor out my cosecant. These both have a cosecant. So when I factor out the cosecant of x, I am left with a cosine squared of x minus 1. And it's the same identity. Cosine squared of x still equals a negative sine squared. And this makes me think, well, cosecant, let's see. In terms of sine and cosine, I think my cosecant is the reciprocal of sine. So I'm actually going to treat that as a 1 over sine of x times this negative sine squared. All right, so I can divide out one of those sines. All I have left is a negative sine of x. Okay, so that's simplified down as good as it's going to get. Okay, and then number 3 here says to factor each expression. When I factor, like if this said x squared minus 1, I would use my difference of squares. I would factor this to be like an x plus 1 times x minus 1. All right, so difference of squares on this. I don't have a plain x, I have a secant that is squared, but kind of the same deal. I'm going to factor this into a secant of theta minus 1 times a secant of theta plus 1. So I factored it with the difference of squares. Okay. And then on part B here, I'm thinking, all right, let's see, they're both tangents. That's a good sign. I'm probably going to have to do like my factor by grouping. This is where I multiply 4 times negative 3, which is negative 12. And And let's see if we can figure out anything that multiplies to be negative 12 and then adds up to, this is a positive 1 in front of my tangent. So what multiplies to be negative 12 and adds up to a positive 1? Let's see here. I could have a 1 times negative 12, negative 1 times positive 12. No, none of those add up to 1. I could have a negative 2 times positive 6 or positive 2 times negative 6. They don't add up to 1 yet, though. Let's see. Negative 3 times 4 for positive 3 times negative 4. These multiply to be negative 12. Actually, I do think we have these ones that add up to a positive 1. All right. So what I've got to do with these numbers is I've got to do some factor by grouping. Like I'm going to treat this 1, I'm going to break that 1 tangent into a negative 3 tangent. Okay, I need some more space here. Negative 3 tangent of theta and a positive 4 tangent of theta. Maybe I'll have to get rid of this. I need some more space. Okay. So I broke that middle piece up, but I haven't touched the minus 3 on the end or the 4 tangent squared of theta at the beginning. I haven't messed with those guys. All right, so if I do my factor by grouping, this first group, their GCF, their greatest common factor is a tangent. I'm gonna factor a tangent out, and I'm left with 4 tangent of theta minus 3, which this actually, their GCF is just like a positive 1. I can factor out a positive 1, and I'm still left with my 4 tangent of theta minus 3. So they have the exact same factor, which is kind of the whole point. That's why we did it this way, because now my overall GCF, the overall thing they have in common is the 4 times tangent of theta minus 3. And the leftovers here are my tangent of theta and my positive 1. So let's see, tangent of theta plus 1. All right, so we have totally factored into these two factors. And the nice thing on this is you can then distribute, if you want to check your answer, distribute and see if it gets you back to what you started with. All right, and then part C here, get rid of this real quick. Part C, if I'm going to factor this expression, I kind of notice that it's not like B in that on part B, I had a tangent and a tangent, like they were both the exact same trig function. But on part C, they're not the same trig function. I've got like a cosecant and then a cotangent. So I think I've got a little work to do on this first. So let's see here. Maybe the fact that this is a cosecant squared. Remember what I did up here whenever I saw like a cosine squared or a sine squared? It made me think of that identity. And I think we have one for a cosecant squared as well. Let's go look at this set of identities. All right, my cosecant squared. Okay, my cosecant squared actually equals 1 plus cotangent squared. So let's see if we can use that to our advantage here. So if I replace my cosecant squared with a 1 plus cotangent squared of x, all right, I still have all the rest of this. I think this helped us out because now they're all cotangents. They're the same trig function. Nice. Okay. So if I combine my like terms, let's see, I've got cotangent squared doesn't really have any like terms. My plane cotangent, no like terms, but let's see, my constants. I have a 1 and a negative 3. So I will go ahead and combine those into a negative 2. All right. So I think this is looking a bit better. I don't have a leading coefficient like I did on B, so I don't think I really need to do the factor by grouping. I'm going to see if I can figure out any numbers that multiply to be negative 2 and add up to negative 1. So let's see, I think I'm going to go with a negative 2 and a positive 1. Those multiply to be negative 2. Negative 2 plus 1 is a negative 1. All right, so we took care of those. And then if this was just like an x squared minus x minus 2, if it was like this, I would just put like a straight up x at the beginning here, right? But this isn't x squared. This is a whole cotangent squared and a whole cotangent. So I've got cotangent of x at the beginning of each of these factors, not just the x, the cotangent of x at the beginning of those factors. All right, so there we go. We factored our polynomial. Okay, and so let's go on to number 4, where they want us to simplify. So I think I'm going to use one of my identities. I know that I can pretty much break everything down into sines and cosines. So let's see if that helps here. I've got sine of t. Cotangent, let's see, tangent is sine over cosine. Cotangent is cosine over sine. Okay, so, and then times cosine of t. I broke it all down into sines and cosines. Let's see what we can do to combine these. I would need common denominators. These are fractions, right? So I would need some common denominators. I think I'm going to multiply this by sine of t over sine of t. Okay, so they have their common denominators. This gives me sine squared of t plus a cosine squared of t. There's my cosines multiplied together. And their common denominator was just a plain old sine of t. Okay. And I hope this is kind of ringing a bell in your head real quick here. Sine squared plus cosine squared. That was one of our identities. Let's look at that. That was this same identity that we used before. Sine squared plus cosine squared equals 1. Okay. So then that helps me narrow this down. This sine squared of t plus cosine squared of t, that is just a straight up 1 over sine of t. And I think the only other thing I can do is the reciprocal of sine, like 1 over sine, is the same thing as my cosecant. So this is my cosecant of t. All right, so we simplified this messy bit they started with down to a single trig function. We got down to just cosecant of t. All right, and we're going to do one more here. Number 5, we're going to perform the addition and simplification. So let's add these together first. So these are fractions. If I want to add fractions, I need common denominators. So we got to mess with that real quick. I'm going to multiply this times sine of theta over sine of theta. And my next fraction, I'm multiplying by 1 plus cosine. This is supposed to be a theta right here. I don't know where that went. 1 plus cosine of theta over 1 plus cosine of theta. Okay, so both of the denominators are now sine times 1 plus cosine. Sine times 1 plus cosine. So that's their common denominator. This is going to all be over a sine times 1 plus cosine. Okay, the numerators though, let's look at this. This first numerator was sine times sine. So sine squared. And this numerator is a 1 plus cosine times cosine. Let me see, I think I'm going to distribute this. So cosine times 1 is cosine, and cosine times cosine is cosine squared. All right, so I at least combined my fractions. It still looks pretty messy though. But I do have kind of something ringing in my head here. Remember that sine squared plus cosine squared that I did in number 4? I kind of see that here, sine squared plus a cosine squared. So you can like rearrange it if you want. It's all addition, right? So I can add in whatever order I want. And so this matches my identity. That is going to be just 1. All right, so yeah, like I said, this identity sine squared plus cosine squared is just a straight up 1. All right, and then that actually, I think, is looking pretty good because my 1 plus cosine in the numerator, I then have sine of theta over 1 plus cosine theta in the denominator. But as messy as this is, I have the same thing in the numerator and denominator. Like those divide out. Those are gone. Anything divided by itself is 1. So I have 1 over sine of theta. Okay, so that kind of puts me kind of where I was on this one, where 1 over sine is cosecant. So this whole messy fraction ended up with a straight up cosecant of theta. I almost wrote a T like this one. It's supposed to be cosecant of theta though. different variable, but same deal. All right, there we go. We totally simplified it down. All right, so I hope this is helpful. We're going to pick up our notes next time I see you. All right, see you guys.